Hello and welcome to Algebra 2 Lesson 23. In this video, we're going to learn about function notation. All right, so we're going to start out by looking at two brief examples here. We have y equals x plus 3, and we have y equals x squared minus 5. So at this point, we know that these two relations are functions. I input something in for x, I get a unique output for y. So as an example, let's say I plug in a 5 for x. 5 plus 3 would give me 8, so my output for y is 8. As I change the value of x, I'm going to change the value of y. So y depends on my input for x. So again, x is the independent variable, y is the dependent variable. It's the same with this example here as well. If I plug in, let's say, a 2 for x, 2 squared is 4, 4 minus 5 is negative 1. If I change the input for x, I change the output for y. So y depends on x. If I say made this 3, 3 squared would be 9. 9 minus 5 would give me 4. So as I change my independent variable x, my dependent variable y is going to change. Now, when we start talking about functions, generally we start out with the typical y equals something. As we move on, we're going to replace that notation of y equals something with f of x equals something. And let me tell you, this is a very big cause of confusion. A lot of students are like, where did y go? Bring y back. Why can't I have y anymore? It's gone and it's not going to come back. Okay, so as you get into higher math, particularly college algebra, they're not going to spend any time explaining that y is the same thing as f of x. They're just going to present it, and you're going to have to move on with it. So I want to take the time here to make sure you understand this. Functions are generally named with f, g, or h. So you'll see f, g, or h. And it might be lowercase, it might be uppercase, whatever they want to use. And typically what you're going to see is, let's say I'm naming the function as f. Instead of y, all you're going to have is f of x. So a function of x, meaning the function depends on the input that is x. So f of x now equals x plus 3. So there's no difference between this and this other than I replaced y with f of x. And I could do it over here as well. Instead of y, let me just write g of x. Okay, g of x. So g of x equals x squared minus 5. So I replaced y with g of x. So there's really nothing to be confused about here. It's something that's very, very easy. You just have to get used to it. I'm just replacing y with f of x. Or I'm replacing y with g of x. Or I could have replaced y with, let's say, h of x. Okay? I'm just saying that I have a function that's dependent on the value that you give me for x. So as another example, let's say I saw y equals x to the 4th power minus 3x plus 7. I could write this using function notation as f of x is equal to, everything is the same, just x to the 4th power minus 3x plus 7. Super, super simple. I just replaced y with f of x. All right, so this notation can immediately be used to evaluate a function for a given x value. So in the past, we've done this, okay? It's the same thing. We're not learning anything new. It's just a different way to notate it. So let's say you saw y equals x plus 3, and I said, let x be equal to 2. What would y be? Well, you would just say, okay, y equals, I would plug in a 2 for x, and I would say y equals 2 plus 3, which is 5. So then we know that if x is 2, y is 5. We've been doing that forever. Now, when I change this up, again, students go crazy and go, what do I do? The notation now will be f of x is equal to x plus 3. Again, I haven't done anything special. All I've done is I've taken y and I've replaced it with f of x. Okay, nothing special is going on. Now, the notation to say let x be equal to 2, we would say f of 2. Okay, so you have your f inside the parentheses. You have the value that you want x to take on. So f of 2 is equal to, replace x with a 2, then plus 3. So f of 2 is 5. This is just saying, what is the function's value when x is 2? What is the value when x is 2? We can see the function has a value of 5 when x is 2. So let's say I tried another value. Let me erase all this. Let's say that I wanted to let x be equal to, I don't know, 7. So how would I ask for that? Well, I would say I want f of 7. Whatever value you put inside the parentheses, you're just saying, hey, if x was 7, what is the function's value? It's the same thing as saying, let x be equal to 7 and find out what y is equal to. Same thing, okay? So the function's value when x is 7, we replace x with a 7. Okay, we just replace x with a 7. You'd have 7 plus 3, that equals 10. So f of 7 is 10. And again, you can relate that to your earlier procedure. If I just plugged in a 7 for x, 7 plus 3 is 10, y equals 10. So y would equal 10, or f of 7 equals 10. The function's value when x is equal to 7 is 10. That's all we're saying. All right, let's look at a few examples here. This is very, very easy, and you won't get into anything harder. When you get to college algebra, you're going to talk about the composition of functions. We're not going to get into that here. I'm going to wait until you get to college algebra to deal with that. But I can tell you that it's not much more difficult, but you need to know how to do the basics first before you get into the more complicated scenarios. So we have f of x is equal to x squared minus 7x plus 2. So if I want f of 0, what am I asking for? I'm asking for the function's value when x is 0. So I would simply plug in a 0 here and find out what I get. So 0 squared is 0, minus 7 times 0 is 0, plus 2, I'd basically just have 2. So f of 0, or the function's value when x is 0, is 2. Then the next one is, I want to find f of negative 2. So if I plugged in a negative 2 for x there and there, I would have negative 2, and it's inside of parentheses because whatever x is, it's squared. X is negative 2, so we square the negative and the 2. Then minus 7 times negative 2 plus 2. Scroll down a little bit. We'll have negative 2 squared is 4. Then we have negative 7 times negative 2. That's positive 14. So plus 14, then plus 2. So 4 plus 14 is 18. 18 plus 2 is 20. So we can say the function's value when x is equal to negative 2 is 20. All right, so next we want f of 5. And I realize you can't see the function anymore, so let me just rewrite it. F of x is equal to, we have x squared minus 7x plus 2. So f of 5 would be what? Plug in a 5 here and here. You'd have 5 squared minus 7 times 5 plus 2. 5 squared is 25, so you'd have 25 minus 7 times 5 is 35 plus 2. So 25 minus 35 is negative 10. Negative 10 plus 2 is negative 8. So f of 5 is negative 8. Again, the function's value when x equals 5. All right, so now we want f of 9. And again, I'm just going to write my function f of x is equal to x squared minus 7x plus 2. So f of 9 is what? I'm just going to replace x with a 9 here and here. So I would have, let me kind of write this down here, 9 squared minus 7 times 9 plus 2. 9 squared is 81 minus 7 times 9 is 63 plus 2. So the easy way to do this is to add 81 and 2 first. 81 plus 2 is 83. Then 83 minus 63 would be 20. So f of 9, or the function's value when x equals 9, is 20. All right, let's take a look at another example. So we have f of x is equal to negative 2x cubed minus 7. We want to find f of 0. So again, all I'm doing is I'm replacing x with that 0. Whatever's inside of parentheses, replace your independent variable with that. So I would have negative 2 times 0 cubed minus 7. 0 cubed is 0. Negative 2 times 0 is 0. So you'd basically have 0 minus 7, which is negative 7. So f of 0 is negative 7. So let me rewrite this down here and we'll scroll down. So f of x is equal to negative 2x cubed minus 7. So let's go ahead and scroll down now. And I want f of 2. So f of 2 is what? Plug in a 2 there. So negative 2 times, you have 2 that's cubed minus 7. 2 cubed is 8. So I'd have negative 2 times 8 minus 7. Negative 2 times 8 is negative 16. So you'd have negative 16 minus 7. Negative 16 minus 7 is going to give me negative 23. So f of 2, or the function's value, when x equals 2, is negative 23. All right, so let me paste our function here. So f of 10. So what am I going to do? Again, all I want to do is plug a 10 in for x. So I'd have negative 2 times, we'd have 10, and that would be cubed, then minus 7. So I'd end up with negative 2 times, 10 cubed is 1,000, right? It's a 1 followed by 3 zeros, then minus 7. So I know that I would do negative 2 times 1,000 first. That would be negative 2,000, then minus 7. This is going to end up being negative 2,007. So f of 10, or the function's value when x equals 10, is negative 2,007. All right, let me throw a little bit of a curveball at you. This is something that really trips students up. So I've explained kind of the basics, and when you use numbers, it's easy to kind of start getting a hold of that. You can wrap your head around it, everything is fine. And everything is fine up until you see another variable that's inside the parentheses. So let's say you have f of x is equal to 3x minus 1, and you see f of a. I can't tell you how many students go ballistic and go, what do I do? It's the same thing. This is what I want to plug in for this. So just like if you had a 3 there, if I had f of 3, I would plug a 3 in for x, right? And then I would just evaluate. Well, if I have f of a, plug an a in for x, I'd have 3 times a minus 1, which is just 3a minus 1. All we're saying is that the function's value, if x was equal to a, would be 3a minus 1. And that's easy to see. You have one x there, just replace it with an a instead of 3x minus 1. You've got 3a minus 1. Okay, so it's very, very easy to do that. So again, our function is f of x is equal to 3x minus 1. So what if you see something like f of a plus 2? So you've got a binomial there. What do I do? Again, if I had f of 3, I'd plug a 3 in for x. If I have f of a plus 2, I plug in an a plus 2 for x. So a plus 2. Use parentheses because it's going to stop you from making mistakes. Just use parentheses whenever you substitute things in. Okay? It'll stop you from making silly errors. So I would have 3 times the quantity a plus 2. Because remember, 3 is multiplied by x. X now represents this quantity. So unless I use my distributive property, I'm not going to get the right answer. Right? I don't want to see this because you'll get the wrong answer. Students will go, okay, it's 3a plus 2. No, it's 3 times the quantity a plus 2. That's 3a plus 6. Okay? So that's what you want. So then I have minus 1 there. All I did was I substituted in for the x there. I plugged in an a plus 2. All I did. All right, so now use my distributive property. 3 times a is 3a. Then 3 times 2 again is 6. Then minus 1. So then 3a plus 6 minus 1 is just 5. So the function's value when x is equal to a plus 2 is 3a plus 5. Again, all I did was I replaced x with a plus 2. That's it. No magic, no trickery, nothing like that. All right, so one more time. We have f of x is equal to 3x minus 1. What if I saw f of z? What do I do? Again, take this and plug it in here. All I'm doing. So I would have 3, plug in a z for x, minus 1. All I did was I replaced the x with the z because this is what it told me to do. So the value of this function when x is z is 3z minus 1. That's it. I just swapped the x with the z. All right, let's take a look at another one now. So we have f of x is equal to negative 5x squared minus 3x minus 7. And I'm given f of z minus 1. So again, I'm just going to take this and plug it in here and here and see what I get. So I would have negative 5 times, I'm going to put this inside of parentheses because I want to multiply by this squared. So z minus 1, that quantity has to be squared and then multiplied by negative 5. Then minus 3 times this quantity, z minus 1. Again, use parentheses, minus 7. So we know how to do this quickly. We use our special products formula. Z minus 1, if we square that quantity, we get z squared minus 2z plus 1. So I'd have negative 5 times that quantity. Again, z squared minus 2z plus 1. Then you think about this as negative 3 times z, that's minus 3z. And then negative 3 times negative 1 is plus 3, and then minus 7. All right, so now I want to use my distributive property here. Negative 5 times z squared is negative 5z squared. Then negative 5 times negative 2z is plus 10z. Then negative 5 times 1 is minus 5. Then you have minus 3z plus 3 minus 7. So now we're just combining like terms. So I start out with negative 5z squared. I can't do anything with that. Then I've got 10z minus 3z. That's plus 7z. Then I've got negative 5 plus 3. That's going to give me negative 2. And then negative 2 minus 7 is minus 9. So the function's value, when x is z minus 1, I get negative 5z squared plus 7z minus 9. All right, so lastly, let's talk about another source of confusion. So a function is generally represented in what's known as explicit form. So this is when it's solved for the dependent variable. So y equals f of x, which equals 3x minus 5. I just took y and I replaced it with f of x. That's all I've done. But y is on one side of the equation. The expression 3x minus 5 is on the other. Solve for y. So when we have this, it's easy to just evaluate for a given value of x. Now, in other scenarios, the function is not solved for the dependent variable, so we say that it's an implicit form, okay? Implicit form. So this means the function is not solved for the dependent variable. Remember that, because you're going to get to calculus, you're going to hear about implicit differentiation, and you're going to be like, what does that mean? What do I do? It means the function is not solved for y. And you need to find the derivative, but you don't want to go through the process of solving it for y first. So remember that, because when you get to calculus, you're going to thank me. All right, so we have an example here. Negative 5 equals negative 3x plus y. So what would I do if I wanted to put this in explicit form? Well, I would just solve it for y. Just simply add 3x to both sides of the equation, and you're done. It's an explicit form. You would have 3x minus 5 equals y, or I could simply say y is equal to 3x minus 5. Using function notation, I could say f of x is equal to 3x minus 5. Again, all I'm doing is replacing y with f of x. But hopefully you can see the difference. In one case, in explicit form, which we have here, it's solved for the dependent variable y. When it's in implicit form, it's not. So y is just kind of jumbled up. It's not on one side of the equation by itself. That's implicit form. So if you get a problem like this one, you've got to do additional work. So you might be asked to, let's say, find f of 3, f of 7, and f of negative 1 for, and we have an implicit function here. We have negative x squared plus y equals 4. So what do I got to do? I got to solve it for y first, then replace y with f of x, then do my normal procedure. Okay? It's not much more work. So I would add x squared to each side of this equation, and I would find that y is equal to x squared plus 4. I could then replace y and say y is a function of x. So I use this notation here, and it equals x squared plus 4. So if I want to find f of 3, what do? I just plug a 3 in here. So f of 3 is what? It's 3 squared, which is 9, plus 4, which is going to give me 13. So f of 3 is 13. If I want f of 7, plug a 7 in for x. So I'd have 7 squared plus 4. 7 squared is 49. 49 plus 4 is 53. So f of 7 would be 53. Then lastly, if I wanted f of negative 1, well, I'd plug a negative 1 in for x. Remember, I'm squaring whatever x is. So negative 1 has to be inside of parentheses because I'm squaring the negative and the 1. So negative 1 squared plus 4. Negative 1 squared is 1. 1 plus 4 is 5. So f of negative 1 is 5. All right, let's take a look at one more of these. And I made it a little bit harder to solve for y. So we want to find f of 0, f of negative 2, and f of 5 for, and we have x to the 4th power minus x squared plus 2y equals 10. Again, solve for y, replace y with f of x. Very, very simple. So let me subtract x to the 4th power from both sides of the equation. Let me add x squared to both sides of the equation. We'll just start with that. So this is going to cancel. I would have 2y is equal to, let's write negative x to the 4th power plus x squared plus 10. Now, to get y by itself, what do I got to do? I got to divide everything by 2. Okay, so we divide both sides by 2. This cancels with this, and I have y is equal to, you'll have a negative, and you could write 1/2 times x to the 4th power, plus, you can write 1/2 times x squared, plus 10 over 2 is 5. So I can go ahead and replace this y with f of x. I can say, let me just erase all of this. We don't need it anymore. I can say y is f of x. Okay, they're the same. And this is equal to negative, and I can write this in a more compact form. Let me just put negative x to the 4th power over 2 plus x squared over 2 plus 5. Let me kind of move these up a little bit. Okay, so now if I want to find f of 0, what do? Plug in a 0 for each x. So I know that 0 to the 4th power is 0. The opposite of that would still be 0. Divide by 2, I get 0. 0 squared is 0. Divide by 2, I get 0. So these two would cancel themselves. You're just left with 5. F of 0 is 5. So now I want to find f of negative 2. So f of negative 2 is what? I would plug in a negative 2 for each x. So I'd have negative, and then in parentheses, I'd have negative 2 to the 4th power. Make sure you use parentheses when you're substituting. It'll stop you from making mistakes. This is over 2. Then plus, I'm going to have negative 2 inside of parentheses, squared, over 2, then plus 5. So negative 2 to the 4th power is 16, but the opposite of 16 would be negative 16. So negative 16 over 2 would be negative 8. So this would be, I'm kind of make a little line there. This would be negative 8. And then negative 2 squared is 4. 4 over 2 is 2, so plus 2 plus 5. So negative 8 plus 2 would be negative 6. Negative 6 plus 5 is negative 1. So f of negative 2 is negative 1. Then lastly, we want f of 5. Let me kind of scroll down a little bit to get that one going. So f of 5. So I would have negative, in place of x, I'd plug in a 5, and that's to the 4th power over 2, plus, I have 5, that's going to be squared, and that's over 2, then plus 5. All right, so let's scroll down and get a little room going. So 5 to the 4th power is 625. So I'd have negative 625 over 2. And then 5 squared is 25. So I'd have plus 25 over 2, then plus 5. Well, I have a common denominator here. Negative 625 plus 25 would be negative 600. So this would be negative 600 over 2 plus 5. We know negative 600 over 2 would be negative 300. So this would be equal to negative 300. And then plus 5, this would end up giving me negative 295. So f of 5, or once again, the function's value when x is 5, is going to be negative 295.